Hello, welcome to software testing. The content for this presentation will be about software development lifecycle and what is software testing, why we should do software testing, types of testing methodologies, difference between white box and black box testing, types of testing, black box testing, types in black box testing, testing life cycle, defect life cycle, error, defect, bug, and failure. Also, we discuss on what is scenario, examples for scenario, requirement for registration, scenarios for registration button, test case for registration button, differences between scenario and test case, differences between priority and severity. Software development lifecycle. We are going to view on the waterfall model of software development lifecycle. So we have various models for software development lifecycle. Maybe it's a Big Bang model, waterfall model, prototype model, or spiral model. Today we are going to view on waterfall model. So what's the waterfall model in software development lifecycle? A project using waterfall model moves down a series of steps starting from an initial idea to a final product. At the end of each step, the project team holds a review to determine if they are ready to move to the next step. If the project isn't ready to progress, it stays at the level until it's ready. Each phase requires well-defined information, utilizes well-defined process, and results in well-defined outputs. Resources are required to complete the process in each phase, and in each phase is accomplished through the application of explicit methods, tools, and techniques. The waterfall model is also called the phased model because of the sequential move from one phase to another. The implication being that systems cascade from one level to the next in smooth progression. It has the following phases of development. What we are seeing here is about the first step for the waterfall model is on requirement gathering. Further on, we will move for the analysis and going for the design, then move for development. We enter into the coding phase. Then comes the testing phase. We go for adapting test cases and test scenarios. After completion of successful testing of the software, we go for deployment, and further we move on for the maintenance phase. What is software testing? Checking the functionality of an application is software testing. Software testing is a critical element of software quality assurance and represents the ultimate process to ensure the correctness of the product. The quality product always enhances the customer confidence in using the product, thereby increases the business economics. A good quality product means zero defects, which is derived from a better quality process in testing. Software is an integrated set of program codes designed logically to implement a particular function or to automate a particular process. Today, software testing is a critical element of software quality assurance, and it represents the ultimate process to ensure the correctness of the product. The quality product always enhances the customer confidence, so we can increase the business economics. A good quality product means a product coming with zero defects, which is derived from a better quality process and testing. Software is an integrated set of program codes designed logically to implement a particular function or to automate a particular process. So to develop a software product or project, user needs and constraints must be determined. So product development is done assuming a wide range of customers and their needs. This type of development involves customers from all domains and collecting requirements from different environments. Various project development is done by focusing a particular customer's need, gathering data from his environment and bringing out a valid set of information that will help as a pillar to development process. Testing the product means adding value to it by raising the quality or reliability of the product. Raising the reliability of the product means finding and removing errors. Hence, one should not test a product to show that it works. Rather, one should start with the assumption that the program contains errors and then test the program to find as many of the errors as possible. So testing is the process of executing a program with the intent of finding errors. Testing is a process of evaluating a system by manual or automatic means and verify that it's satisfied specified requirements. So the process of exercising or evaluating a system or system component by manual or automated means to verify that it satisfies specified requirements or to identify differences between the expected and actual results will be the software testing. So we have to write test cases and find errors from the expected and actual results. So we are what the product is going want to. So we are doing software testing to support the business. If there is a defect in the software, it will affect the business and to ensure the quality of software application. So the software testing is done for ensuring the quality of software application. So before we launch the software to the customer, every defect should be identified and it should be resolved. So it's a very important process to find the defects, to write test case, to create test scenarios, and to put the test cases and check whether the scenario is perfect. The writing test cases to find the differences between the expected result and actual result. So that we can find the defect and we can resolve it. So that's the process of software testing, and that's the need for the software testing in the software development lifecycle. Types of testing methodologies. White box testing. Testing the source code of an application. It is done by developers. Black box testing. Testing the UI and functionality of an application. It is done by test engineers. Gray box testing. Testing the source code and UI and functionality of an application. It is done by either developers or test engineers. Difference between white box and black box testing. White box testing. Manual testing, writing source code for an application and testing each and every lines of code manually. So in black box testing, the manual testing process involves testing the UI and functionality of the application manually. So when it comes for automation testing, in the white box testing, it involves writing the source code for an application, writing the program to test the development program using a tool. So when it comes for black box testing, in automation testing, the process involves writing a program to test the UI and functionality of an application using tool. Run the test program in the tool, example Selenium tool or Jira, like that. For example, in white box testing, this automation testing will be done by the Unit tool in Java, and in .NET, that Unit tool. So here in this case of black box testing, we got an integrated set of development environment that we have source code written by developers. We compile the source code and we compress to come with the software. That is, we already performed a white box testing and we set integrated development environment to conduct black box testing. So we got the software here, and what's the requirement? That is the scenario here for the black box testing is to check the login page. So the requirement is to check the login page. So for login page, we are entering the valid details and we are going for the home page. So that's the scenario. So we enter the valid details and final output is to enter the home page. So this is the requirement, the scenario for the conducting the black box testing. And in the testing environment, we are going to write test cases for the login page. So we enter the valid details and we are checking whether the software is doing its functionality, whether it's going for the home page. So this is the process of conducting a black box testing. Further, we can the techniques for black box testing could also be the equivalence partitioning. We can go further techniques for conducting the black box testing. That might be the equivalence partitioning, boundary analysis, and error guessing. So in equivalence partitioning, we can check the program for the credit limits. For example, we have to check for the credit limit between 20,000 and 50,000, between 20,000 and 50,000. So you can check by equivalence partitioning. So in case of equivalence partitioning, we have to check for less than 20,000. That means invalid. Between 20,000 and 50,000 means it goes for valid. And we can have the third option. We can go for if the input is greater than 50,000, it becomes invalid. And we also can do the black box testing by another technique like boundary value analysis. In this boundary value analysis, if you want to check the input data between 20,000 and 50,000 means we can go for three conditions. One is the low boundary plus or minus 1. That is, low boundary is 20,000. So low boundary plus or minus 1 is it's 19,999 and 20,001. And on the boundary, we can go for checking on the boundary, that is 20,000 and 50,000. And upper boundary plus or minus 1. So upper boundary is 50,000. So if we go for checking for upper boundary, then we can test by inputting like 49,999 and 50,001. So also we can go for error guessing. Suppose for the explicit dates like 29th February or 9/9/99. So we can, based on the experience of the test engineer and by intuition also, we can go for error guessing in the black box testing. So that's the black box testing performed by the software tester. So let's see about the white box testing and black box testing. So white box testing technique, it generally examines the basic program structure and it derives the test data from the program logic, ensuring that all statements and conditions have been executed at least once. White box test verifies that the software design is valid and also whether it was built according to the specified design. So different methods will be statement coverage executes all statements at least once. Decision coverage executes each decision direction at least once. Condition coverage executes each and every condition in the program with all possible outcomes at least once. So in black box testing, the technique treats the system as a black box. So it doesn't explicitly use knowledge of the internal structure. Black box design is usually described as focusing on testing functional requirements. So black box testing is conducted on integrated functional components whose design integrity has been verified to completion of traceable white box test. Black box testing traces the requirements focusing on system externals. It validates the software meets the requirements irrespective of the paths of execution taken to meet each requirements. So this can be achieved by some successful techniques. We can go for equivalence partitioning, boundary analysis and error guessing. So black box testing, it's conducted in an integrated functional components. So all the components are integrated and it's been verified to the completion of traceable white box test. So we are integrating all the functional components and going for black box testing. So the requirement for black box testing and the testing environment, everything is set up for performing the black box testing. So black box testing we can do by equivalence partitioning, boundary analysis and error guessing. So for example, in equivalence partitioning, that basically it's a process of methodically reducing the huge set of possible test cases into a much smaller but still equally effective set. For example, a program that edits credit limits with a given range 20,000 to 50,000 would have three equivalence classes. That means it could be less than 20,000, between 20,000 and 50,000, or greater than 50,000. So we have to do by boundary value analysis. We can so in boundary value analysis, it might be of lower boundary plus or minus 1. That might be 19,999 to 20,001. On the boundary means 20,000 and 50,000. Upper boundary plus or minus 1 in the sense it might be going for like 49,999 and 50,001. So if you are going for black box testing for a given range in between 20,000 and 50,000 means in equivalence partitioning we have to check for less than 20,000, between 20,000 and 50,000, greater than 50,000. In boundary value analysis, we can further go for checking by inputting the data for low boundary plus or minus 1. That means 19,999 and 20,001. So on the boundary, that is 20,000 and 50,000. Upper boundary plus or minus 1. That is, upper boundary is 50,000 plus or minus 1 is 49,999 and 50,001. And we can also go for the range testing by error grazing. This is based on a theory that test cases can be developed based upon the intuition and experience of the test engineer. Manual testing. Checking the functionality of an application is called software testing. In the types of testing, the manual testing involves checking the functionality of the application. Drawbacks is manual regression testing. So in automation testing, it is the process of testing the application automatically using the automation tool. Advantages: saves time and money. We can easily do compatibility testing by running the test script in multiple platforms simultaneously. This is called parallel execution. We can generate the reports automatically. What actually a software tester going to test in the software by performing the method of black box testing. So we can classify the black box testing in two types. That is one is functional and the other is the non-functional. Under the functional black box testing, we can see the smoke testing and functional testing, and we can go for integration testing. So we can test each module of the software application individually. So followed by the white box testing. So black box testing is just initiated by doing test by performing the unit testing, like testing each module, and following that we can go for testing the integration, perform the integration testing. That is, the individual components are combined with other components to make sure that necessary communications, links, and data sharing occur properly. It is not truly system testing because the components are not implemented in the operating environment. The integration phase requires more planning and some reasonable subset of production type data. Large systems often require several integration steps. So the integration steps, we can see the bottom-up testing and top-down testing like that. So, and in system testing, the system testing phase begins once modules are integrated enough to perform tests in a whole system environment. System testing can occur in parallel with integration test, especially with a top-down method. So when we go for top-down method, we can parallelly perform system testing. So that is began once the modules are integrated enough to perform tests in a whole system environment. So after finishing of the integration testing, comes the system testing. So then will come the retesting, regression testing. Regression testing, it confirms the implementation of changes have not adversely affected other functions. Regression testing is type of test as opposed to a phase in testing. Regression test applies to at all phases whenever a change is made. So whenever a change is made, we have to perform regression testing because the implementation of change have not adversely affected other functions. So then comes the exploratory testing, and we can perform the acceptance testing. User acceptance testing and installation testing is coming after the exploratory testing in the functional black box testing. When it comes for non-functional black box testing, we'll go for the compatibility testing, and the performance is all non-functional. Just we'll check for the compatibility, performance, usability, ad hoc, accessibility, globalization, recovery, aesthetic, and security type of testing. Now we can see the testing life cycle. So when you see the flow chart, you can see what's actually a testing life cycle process involves. It basically, first we have to do the system study. So after completion of software, after the traceable white box testing is done, then we follow the black box live testing. So that's where the testing life cycle is beginning. So we perform the system study, we write the test plan, writing the test cases, preparing the requirement traceability matrix, that is RTM, and we have to execute the test cases. After executing the test cases, we can track about the defects. So we have to prepare the test execution report, and after that we have to go for retrospective or post-mortem meeting for the test execution reports. So we can enhancedly study about the testing life cycle. Basically, it involves the test plan preparation. So what's actually going to be done in the testing life cycle. When the process initiates for a software, then we have to go for the test plan for preparation. So write the test plan, we have to design for the scenario test cases and test execution like that. So how we are going to prepare the test plan? The software test plan, it is the primary means by which the software testers communicate to the product development team what they intend to do. So the purpose of the software test plan is to prescribe the scope, approach, resource, and schedule of the testing activities, to identify the items being tested, the features to be tested, the testing task to be performed, the personnel responsible for each task, and the risk is associated with the plan. The test plan is simply a byproduct of the detailed planning process that's undertaken to create it. It's the planning that matters, not the resulting documents. The ultimate goal of the test planning process is communicating the software test team's intent, its expectations, and its understanding of the tests that to be performed. So this is about defect life cycle. So once we perform software testing, we can come with the defect, that is the difference between the expected and actual results will follow by the defects. So let me see what's about there in the defect life cycle. So when a defect is identified, it's given a status of new, and it's going to be assigned to tester, software tester, and let's actually see what's going to happen in the bug life cycle. So it goes to a tester. The tester is going to open the defect, and the tester, after opening the defect, he wants to send the details of documentation to the developer. If the documentation of the defect is being accepted, it moves for the next step. So defect is identified, it is predicted as new. Now it's going to be getting assigned for software tester, so software developer. Okay, because the set of documents which reveals about the identified defect has to be sent to the developer, the assigned developer. So now the developer is going to fix the defect. So identified new defect is assigned to the developer and it's being fixed by him, and the bug life cycle then follows. What's happened to the fixed bug by the developer. So now you have to go for the regression testing. So a change is made, so we have to check whether the change is not affecting, the implementation of change is not affecting the actual product. So regression testing follows the after the fixed status of the defect. So the fixed status, it can be deferred or it might be a duplicate defect. So it cannot be fixed and we cannot reproduce the defect, or it is invalid or rejected, or the fixed defect can be request for enhancement. So these are all the possibilities that the developer can report for after identification of the defect. If either of these report is given by the developer, then the defect has to be rechecked, and if again the defect was valid, so if it is coming as a valid defect, then again the fixed developer going to the developer has to rectify the defect and have to give the status as closed or have to reopen. So the final status for a defect will be either it is closed or it is reopened. So that's the cycle of the defect. So once the defect is identified, it is given a status as new. When a defect status is new, it should be assigned to a developer. So developer has to fix the defect. Okay, and the defect has to be followed by the final status of closed or it has to be reopened. So that's the life cycle for the defect. So it should be a process in the software testing life cycle. What is error, defect, bug, and failure? A mistake in coding is called error. Error found by tester is called defect. Defect accepted by development team, then it is called bug. But does not meet the requirements, then it is failure. So that has to be very well understood in the software testing life cycle. So if it is a mistake in coding, that will be called as error. If the error is found by the tester, then it would become defect. So if the defect is accepted by the developer, then he will give the status for as bug. So if it is not meet the requirements, then it's failure. So how to report the defect using Excel sheet that we have to understand and that we have to make understand while we study on the software testing life cycle. So how we are going to report the defect using Excel sheet. To report the defect using Excel sheet, mention the feature that been affected. That you have to mention the test case ID, which fail. You can even mention any other which are dependency on this bug. So this, the actual behavior and the expected behavior has to be mentioned in the Excel report, and your test setup used during testing, steps to reproduce the bug, and some additional info. Attach a screenshot if it is a graphical user interface bug. So always attach a screenshot while reporting a defect for the tester. So it's very essential to mention the screenshot for the defect report. So which other features it is blocking because of this bug that you are unable to execute the test cases. So you should also mention because of the defect or bug which all other features are going to affect, and might be you cannot able to continue to execute the following test cases that you must have to mention while reporting the defect to the software developer. How much time you took to execute the test case or follow the specific test case which leaded to the bug. So these are all the main points, that is the spotlights that we have to be highlighted while reporting a defect to the developer. So because of the defect, what feature is being affected? First of all, we have to give the test case ID. So by which test case ID we found the defect. So by finding the defect, which feature has been affected, that you have to mention while you are reporting about the defect to the developer. So what actual behavior of the defect? So because of the defect, what's the actual behavior? What's the expected behavior? So that you have to mention in the report. So your test setup used during testing, what the test environment, the system setup, everything has to be mentioned. So what are the steps to reproduce the bug? How you identify the bug? You have to write down the steps, and so you have to attach a screenshot if it is a graphical user interface bug. So other things like you have to mention is how much time you took to execute the test case or follow that specific test case which led to bug. That has to be mentioned in the defect report. These are all should be understood while studying about the software testing life cycle, while understanding the terminologies of error, defect, bug, and failure. So here in this case of lab, so now we are going to see about what is scenario. Testing an application in all possible ways. To find the defects, we have to identify the scenarios first. Positive scenarios may be testing an application with valid inputs. Negative scenarios will be testing an application with invalid inputs. So that scenario has to be mentioned in a test plan. So examples for scenario means we can see the scenarios for pen. Positive scenarios means check if all the parts of the pen is fitting properly and no loose fitting. That is installation testing. Check if the pen ball is fitted properly and ball is moving with ease. That's installation testing. As if environmental conditions like at room temperature and different climate conditions. These are the examples of scenario written for a pen. Requirement for registration. We have to find or write test cases for each functionality, and we have to understand about the requirement for the functionality, either it is fulfilled, and we have to write test cases for that functionality. Scenarios for a button. Test case will tell how to do. Scenario does not have navigation steps. Test case have to write from that point of view, like you have to open the browser, either you can go for a scenario. Scenario will tell what to do. Test case will tell how to do. Scenario does not have navigation steps. Test case have navigation steps. Scenario will not tell where exactly the defect is. Test case will tell where exactly the defect is. So while you want to report the test case to the developer, you have to explain the scenario and in which scenario you find the test case. So scenario will not tell where exactly the defect is. Test case will tell where exactly the defect is. Differences between priority and severity. Priority, how fast the defect has been fixed by developer, that will be conveyed by major, minor. Okay, so priority is in the developer point of view, and severity is from the customer's business point of view. So we have to assign the status for the defect by priority and also by severity. So that's the software testing life cycle that we have studied.